So hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. So in our previous video we discussed about the five problems, or the challenges that the machine learning engineers face, and I also gave the solutions to them. And I told you, right, that I will be discussing another five challenges in my next video. So here I am for you all to discuss the five more challenges that the machine learning people face in their daily lives, and I would also be giving their solutions to it. So just make sure that you watch the video till end so you don't miss any. So this is our second part of the challenges in the machine learning problem. So the sixth challenge, which the machine learning people face is around the feature engineering and selection. Feature engineering and selection. So, not all features, contribute to the prediction. Some may add noise instead of the useful information. For example, if you want to, predict that the person is having diabetes or not, and one of the feature is like if he had house or not. So this feature, I don't think so, is helpful in predicting that whether the person is having diabetes or not. So, not all features contribute to the prediction. Okay, some are just for the noise purpose. Okay, for example, another example I would like to give is like predicting the marathon participation. So the useful features for predicting the marathon participation would be the age, the fitness level, and the past running experience. And the irrelevant features would be the favorite color or the birth month. Like these are really irrelevant features, right? So the feature engineering involves creating, selecting, and transforming the features to improve the model performance. So how do you do that basically? So you use the techniques like PCA. Use techniques like PCA. PCA stands for the principal component analysis, or you can also use the correlation analysis. Or you can also use your domain knowledge, of course. For example, if someone is from medical background, they can use their domain knowledge, like what features are important for predicting and what features are irrelevant, right, to select the relevant features. So these are the some of the techniques which you can use for the feature engineering or the feature selection to select the relevant features. Now, the seventh, the most important challenge that usually the machine learning engineers face is around overfitting. So, overfitting is like memorization instead of learning. Overfitting refers to memorization instead of learning. So, overfitting. So, when a model, memorizes the training data instead of learning patterns. For example, the model performs well on the training data but poorly on the unseen data. For example, I may give like a student memorizing the answers instead of understanding the concepts. Some some students just learn the things by heart, and they don't understand the concept behind that. So they really fail in their real exams. So the model creating an overly complex function to fit every training point is like poor generalization. That does not mean that your model is performing well. That simply means that your model is like learning thoroughly and not understanding the concept. It's trying to fit in every training point by using the so complex functions, not knowing the fact what these complex functions are for. So this is known as the poor generalization, and solution to this problem is like you can use techniques like cross validation, and you can also use regularization like L1 and L2, and you can also prune the data like pruning of the data. Okay, pruning of the data for the decision trees, because you do pruning in decision trees only. Okay, And you can also drop out, but drop out in which? Drop out when you are using the neural networks. Okay, you can also drop out the data when you are using the neural networks. So these were some of the steps which you can use to prevent the overfitting in your model. So the eighth problem that the people face is around the underfitting. So underfitting is basically the oversimplified model. So, underfitting is like when a model is too simple to learn the patterns from the data. For example, a linear model trying to fit highly on a nonlinear data. And the problem with this is that a model fails to capture the complex relationships, leading to the poor accuracy. So, in the case of underfitting, now the accuracy of the model will be really really poor. So, the solution is to this problem is that you can use more complex models. Use more complex models. Also, you can do feature engineering, and you can also increase the training time. So, this was some of the techniques you can use to prevent your model from being underfitted. And next, which we're gonna discuss is around the software integration challenge, which usually the machine learning people face. Software integration challenge. Okay, so machine learning models now need to be integrated into real world applications, correct? For example, a fraud detection model needs to work inside a banking system. So what would be the challenges they would face? Compatibility with different programming language like the Python, the Java, or etc. Deployment on the mobile, web, or the cloud platforms, handling the real time predictions efficiently. So for this, what you can use is you can learn ML OOPS. This is basically the machine learning pipelines, and you can deploy your models using model deployment using AWS, GCP, Docker, or the Flask, and you can also use the Fast API. Okay, so these are some of the techniques you can use for deploying your model before going into the production, and you can integrate the with the software, and your challenges may be reduced. Okay, so the 10th technique which someone can use, or which usually the people who do the machine learning phase, is around the model deployment. Like most people just make their model but never deploy it. They just fear from deploying it. Okay, so model deployment and cost issues which the people mainly face. So deploying an machine learning model requires computational resources, right? Like the CPU, GPU, cloud services, etc. Also, the inference cost means the making predictions can be expensive at scale. For example, if a machine learning model serves 1 million users daily, the cost of running the cloud servers will be really really high. So the solution to this problem is like optimize your models using the model compression techniques. Okay, so if the model is optimized, the inference cost will be less, so you can optimize the model. Okay, optimize the model using model compression techniques. Also, you can use the quantization. Also, you can use the serverless deployment option. So these were some of the techniques, which you can use to solve the challenges which you face during your machine learning. So the key takeaways of, both the videos were this: that data is the foundation of machine learning. And without the quality data, models will fail. So always validate the data set representation to avoid the biased results. So balancing, model complexity is really, really important. So avoid both, like avoid the overfitting, at the same time avoid underfitting too. So machine learning is not just about training the models. Deployment, scaling, cost management are equally crucial. So MLOps is the future. Knowing how to deploy and manage the models will set you apart in the industry. As the machine learning model evolves, solving these challenges efficiently will define the success of the real world applications. So thank you for being with me till the end of the video. And if you found the video helpful, just like this video, subscribe my channel, and do not forget to hype my video. Meet you in the next tech update or the technical knowledge video. Till then, bye bye.